Hi, how's everyone doing today? Welcome to edition 3 of Chat with Chet. I'm Chet. Luckily, it looks like we've ironed out most of the issues we have with starting streams, so that's exciting. I'm going to vamp for just a second in case people are late joining us. It's a lovely day here. The sun's actually out, unlike every other time that we've done this. So that's exciting. I'm going to go for a walk after this, which I'm very much looking forward to, and get some exercise. Thank you, Thomas Peters, for saying that this is a much better start. I feel infinitely better and definitely spent some time beating my head against the wall with this the last couple of days, figuring out exactly how to make it work. That being said, just wait for the disaster about midway through that something goes wrong, because that's how these things go. So today we're going to dive into using EOS software and Disguise. We're not going to go as far as working with Sock Puppet, but we're going to look at more of what I do as a theatrical programmer and how I'm interfacing with the Lightboard programmer. There's going to be some things that I recently have figured out how to do, with special thanks to Scott Tusing, who helped me work with some OSC stuff and figure out how to more effectively use OSC. And we'll take a really brief look at something that doesn't work yet, but we are requesting both ETC and Disguise take a look at so that we can try and get the final last little bit I've been waiting to get into Disguise for literally 3 years now. So let's go ahead and let's get started, shall we? So I'm going to fire up my project here. Chat with Chet 003. My computer is just screaming at me every time I do this. The Surface Book 2 is a really great laptop, but this is a little bit to actually prep a timeline with just some cues so that we have them. So to split a timeline, the shortcut key is Alt-S. And I'm going to add a tag. So tags are, in Disguise, how we differentiate where a cue is going to be. And we put our tags at the start of sections. The type of tag we're going to use is a cue tag. There's also timecode tags and MIDI tags. Timecode, if we're going to chase timecode. MIDI is not actually MIDI show control. MIDI is only if you're going to control off of a MIDI note itself. So we'll set it to a cue tag, and we're just going to name this Q1. And I'm going to go ahead and just throw some media up so that we have something else to look at while we're doing this. We'll have Ada come in. This will be Q2. And this time we'll go to George, ever popular. We'll play universal crossfade of 2 seconds. This tag can be Q 3.5. We'll use the ever popular chevrons. And for this one, we'll just go ahead and do a fade to black over 5 seconds. And this will go ahead and be Q4. Give this a 2-second fade. We're just going to do some nice fades so that everything is smooth. Great. So really quick, easily prep timeline. If we step through that, we have Ada fade in over 2 seconds, George fade in over 2 seconds, chevron fade in over 5 seconds, and then a nice fade to black. I'll just go ahead and hit back top of timeline. So for OSC control, we need a device, because devices are how we do outside communication with D3. So we'll right click on our device manager, make a new device. There's a pre-made OSC one, so I'm just going to go ahead and grab that one. The OSC device is going to allow us to send and receive OSC data. OSC, or Open Sound Control, is a protocol that comes out of Berkeley. And for many years, I've referred to it as MIDI 2.0 because it's, for a long time, we've basically been bastardizing MIDI and using MIDI to do a bunch of stuff that originally the spec wasn't designed to do. MIDI show control got built off of it. And then OSC came along, which is a really great, robust format. And I prefer almost entirely to MIDI at this point. MIDI 2.0 has been announced, and we'll see how that goes. But in this case, I don't particularly... MIDI 2.0 is probably another 2 or 3 years down the line, so it's not going to do us much good. It doesn't exist in D3 yet. It doesn't exist in EOS yet. So we'll stick to OSC. An OSC message has two parts. There's going to be a string and an argument or a series of arguments. But that's putting a bit of the cart before the horse. Let's set up the pieces that we need for it first. So we need to both send MIDI and receive MIDI in OSC. And I'm going to cheat and look. I'm actually using my secondary laptop as the send and receive for this. So my secondary laptop, which we'll look at, is running the EOS Nomad software. And its current IP address is 192.168.1.160. So this send is D3 sending data from it to the opposite computer. We'll put in the IP address of my laptop here in the send port over on EOS so that it can send data back. We use two different ports because OSC is a UDP send, so it's a one-way communication. Basically, we're both throwing packets back and forth, but unlike TCP where you're required to have a handshake, that doesn't exist in this. And give me just a moment to make sure that no one is asking any questions in the chat. Nope, we're good so far. So, put in the IP address that we're sending to, the ports that populate. D3 uses the default ports used in Touch OSC, which is a really great app for one's phone if you want to do control through your phone. I like it as a way of being able to see some information on the timeline because D3's transport implementation has a lot of information about where playhead is, next section, if you're currently playing, all of that. I'm not going to set up my phone for this today. I'm just going to do OSC communication from the EOS. And we're actually going to look at some pieces of that transmit that are really helpful that honestly are great for your operator to see. Receive port 7401. One thing to note is if you want to see a better phone application than Touch OSC, I strongly suggest Lemur. Lemur's kind of become my go-to favorite. And that's what I use whenever I'm teaching trainings. So I'm going to shrink this down and this down because we don't need it for the moment. So I put in all my send information. And I'm going to do one other thing to be a little bit tricky so that we can stay isolated to this screen. I'm going to make a new video layer. Patch to our main surface. And I'm going to choose video in 1. And you'll notice nothing's happened here because I haven't patched anything yet to video in 1. But if I pull up my video input patch editor, I can select video input 1, toggle down here, and I can give it an input. So we're going to use something that just recently went gold in version 17 of Disguise, which is NDI. Now you see, this is the EOS software for my laptop. I basically routed that through the network back into my computer. So that way I can do everything inside Disguise and we can see it at all times. So let me just minimize that. Puck, let's move you up. Fine, Puck, we'll move you manually. And I'm also going to turn off my projector label so we don't have that red glow. So this is the EOS software in its live table form. Y to close that. So the first thing we're going to have to do is go into Setup, which this triangle will open our menu, and we'll go to System Settings. And we want to go to the Show Control Settings for OSC. Currently, OSC Receive and Transmit are both enabled. And now we have to put in our OSC Receive port and our OSC Transmit port. Receive port, Transmit port. So remember, if we look back here at OSC1, we're sending down port 7400, which means that our receive port on this is going to be 7400. And our transmit port is going to be 7401. Now we need to put in what the transmit IP address is as well, which in this case is going to be 192.168.1.171. There's a couple other ways that we can enter it. I'm going to go ahead and enter that by default. So I'll just click down here, 192.168.1.171. Enter. So you can see, I'm really bad at typing. .1.171. Much better. So the pieces to communicate are there. Now, if we're doing this in a setup that is actually more sorry, one moment while I gather my thoughts. If we're doing this in a setup that's in the real world, one thing that you'll notice about that is it's missing something very important, and that's we don't only want to hit one computer. If I'm doing this in a full network environment, I'm either going to be hitting multiple computers for the understudy through broadcast IP or through discrete IPs for each one. So if we were going to do this through broadcast IP, I would set the IP address on the transmit address here to be 192.168.1.255. My next lecture is going to go into more of a overarching discussion of IP addresses and how all of that works. Broadcast basically means that you're going to send to everything in that environment. Anything that's in the same subnet mask will receive it. So that's the way that we've done it for many years now if we're going to use OSC control. The other way that recently got added to the software that's really exciting is I can add multiple UDP destinations in here by putting the IP address : port, next IP address : port. So in this case, it would be 192.168.1.171 : 7401, because that's my receive on D3, 192.168.1.172 if that's the next computer that needs to receive it, : 7401, so that we can add multiple computers there. It's been a really beneficial means of being able to define discretely what computers we're hitting. So now that that's set up, we can go to the Diagnostics tab, which is tab 99. And if we scroll down here, I can turn incoming OSC on, and we can see nothing's coming in. Obviously, we've done something wrong. It's not that we've done something wrong, it's that we're not quite there yet. There's one final step for this OSC communication to happen. And that is, if we right-click on transports, I don't have a transport built yet. So there's two types of transports, remote transports and local transports. Remote is if you're going to control the session. Local is if you want an editor computer to be controlled by, say, having a phone sitting in your lap so you can go through transports there. I rarely use the local transports. We're going to use the remote transport. We'll make a new event transport called EOS OSC. Its event transport type is OSC. So we have to define the device. In this case, it's OSC1. And so you can see, the moment we did that, we're getting a lot of packets in because we are now receiving all of D3's information. So we'll dive some more into that in a second. I want to finish setting up what we need on the EOS side. I'm going to go back to live table and I'm going to record a few queues. Q1, Q2, Q3.5, and Q4. So record 1, record 2, record 3.5, record 4, go to Q1. So now, if we look at our PSD, I've got those 4 queues built out. So we're ready for sending that information to control D3. We can't quite do that because we need to tell the EOS what to send to control D3. So I just toggle down the input messages on the OSC transport. These are all the messages that D3 is listening to that will allow it to control things. Play, played end of section, loop section, stop, previous, next, return to start, previous track, next track. The important one for us is going to be Q, /D3/show control/Q. So this is going to allow us to go directly to a queue. Yes, we could program the entire show by sending next section from the EOS, but that means that if we get off, if we have to go back a queue, everything gets messed up. Using queue numbers to define everything, then we'll always be locked in properly. So /D3/show control/Q is the command for that. And we're going to go back into our system settings, show control, OSC, OSC Q send string. And that's going to be /D3/show control/Q. Now we're going to do something a little bit interesting here. We're going to use equals %3, %4. And the reason that we're using %3, %4 is that's defined in the EOS settings. %3, %4 means we are sending, or we are listening to rather, the queue whole number only and the queue point number only. So this is where it gets a little bit tricky. If you've looked into transports in D3, everything's based off of the original DMX transport, which was the first way of doing it, and is still kind of the in vogue way of doing it in Britain. The DMX transport, you have 3 channels of control. Those 3 channels correspond to 3 parts of the queue tag. So for every queue, you will have basically channel 1, channel 2, channel 3. The way I've seen that used in London is channel 1 will be the hundreds place and the thousands place if you get up there. Channel 2 will be the tens and the one place, and channel 3 will be your point place. So Q 125.5 would look like 1.25.50. Basically, D3 is listening for multiple arguments. And when we are sending this string from EOS, we're sending 2 arguments. The first argument is going to be the queue whole number. The second argument is the queue point number. Now that that's set up, I can actually go back to live. And if I hit spacebar, let's make sure our transport's engaged. Engage our transport. Start playhead moving. And when I take my next cue, that should have taken us, but it did not. Let's see. Oh, there we go. Go back to Q1. So I'm only triggering successfully off of Q 3.5 right now. So I wonder if this has changed. I seem to have something set up incorrectly. So let's take a look at system settings. /D3/show control /Q equals %3 %4. Q whole number part. That should be everything correctly. Interesting. I'm going to do one thing and change this feedback interval to slow down our send and see if that helps us. I think I've actually just super saturated my network with NDI and everything else, which is unfortunate. /streaming. When I was testing this, I wasn't streaming at the same time, so that may have been a mistake to try and do all of this through a wireless network. And let that be a lesson for the next time for everyone. Anyway, these are now locked together so that we're triggering off of it. One thing that we do want to do when we're doing this is if we go back into the OSC, the queue play mode, we want to set it to be play to end of section. That way, whenever we see the queue, we get into the normal play mode that we want to be in. Yeah, I'm dropping packets really badly, unfortunately. It's only going to get worse as we do the rest of this, so that's fun. So this is how we line up all the queues for disguise triggering. You can see here, whenever we're sending queues, we can actually see them triggering here. And you can see this is what's telling me I'm dropping queues. If I go back to Q1, you can see I have Q1 typed in there and I hit enter. I'm not receiving that integer here. And this is the danger of D3 and why, or the danger of OSC rather, and why you want to make sure that you have a robust network setup so that you're properly receiving everything and not dropping packets. Yeah, I'm saturating my stream right now and getting lots of angry messages about it. So that explains why that's failing, unfortunately. So let's keep cleaning this up some. This is our method of controlling D3's timeline. And so now whenever we take a go in the EOS, we'll be receiving that information. Back under the transport, we have these output messages. So these are all the messages that D3 is sending back. And you saw me change this output interval earlier. I rolled this up so that we're not sending as many messages per second. In this case, we're now at 3 seconds per message. We're sending let's pull up the other one too, because we can't see here. On the send, notice that we can support message bundles and verbose sending. Verbose sending means that in the console, we'll see everything that we're sending. If I turn it on, you can see I'm sending all this information every 3 seconds. We'll turn that off so we stop spamming the console. Message bundles means that we're sending all of our output messages as one big group, as opposed to sending these out as individual messages. So one thing I'm going to do to stop saturating the network quite so much is delete a bunch of these that I don't need. I'm going to leave section hint because we'll use it to demonstrate something that won't work later. And we're going to change heartbeat in just a second too. So now if I turn on verbose sending again, we can see much smaller packet being sent. All we're sending is the heartbeat itself and the section hint, which is telling us where we are in the current, counting down to the next queue. Those are really my two favorite output pieces. Heartbeat tells us that we're still communicating, and section hint is really helpful for knowing exactly where your playhead is. So let's go back to our EOS settings. Is there a way that we can get this heartbeat into the EOS so that we can see what's going on and make sure that we have connection to Disguise? There actually is. And so to do that, we'll open up our transport again. And we're going to change the name of the heartbeat. /EOS /SC /D3 heartbeat. So /EOS, we're sending to the EOS into their show control library. EOS is defined so that in the show control tab, you can set this up and be receiving it. It means that anything with this affixation will receive that information from. So let's take a look at the show control tab, shall we? That's tab 11. And so the show control tab is completely empty at this point. So I'm going to go ahead and add an event. Event 1. And in event 1, we're going to have list 1. And I'm going to call it D3 heartbeat. So this is a little harder to do because we don't have access to the full surface. I'm just doing this on my computer. So up here under soft keys, I'm going to choose type, network. So now it's a network send. External, on. So now we're listening to an external one. So I need to set what that input's going to be. So we're going to come up here, set input string. Oh, whoops, clear out this. Input string, let me check that syntax because I obviously have it wrong. Choose our input. For our action, we're going to set it to be submaster 1. And over here under network, we're going to set it to be D. Sorry, just clearing that out. Back to show control. Input 1/1 is going to be input string D3 heartbeat. So now we're listening for the D3 heartbeats. And what the D3 heartbeat's going to do is bump sub 1. So if we come over to our submasters, I'm going to make sub 1. Its uptime is going to be 0.2, dwell time 0.2, downtime 0.2. And now I do believe that this is enabled. D3 heartbeat, inputs D3 heartbeat. So on the submaster, you can see that this, let me show it to you in D3. This here is pulsing every 3 seconds. That's when it receives the OSC data. So that will correspond to one of the faders on the actual EOS surface, and it will basically be blinking on and off so that we see it actually receiving that data. So it's just a verification for the operator that, hey, network communication between these two things are good. It's a comfort thing, essentially. So the last piece we're going to show how to do today is using D3 as, or using the EOS as an override. And one of the classes I have coming up later is going to be a discussion of how we use DMX to drive projectors. In this case, I'm just going to go ahead and make a DMX lights control layer, which I would have a lights control layer per projector to control them. And under value, we can right click here and I can give it an expression. OSC colon .d3 .override. So now I'm listening for the string /d3 /override, and then whatever that value is going to be, that value will change whatever is written into value 1 here. So back here under macro editor, I can make a new macro, macro 1. Let me check my notes. So the macro content is going to be string output, or send string, sorry. Send string /d3 /override equals 255. And then you can see here it says press select to save or escape to cancel changes. Under my soft keys, I can choose select. And we now have that macro built. So in D3, if I send macro 1 from the EOS, you can see that value snap to 255. Back in the EOS, I'm going to add a second macro, macro 2, which is going to send string /d3 /override equals 0. And again, we will choose to select that. And now macro 2 enter drops us back down to 0. So what this means is we've essentially built a means of doing overrides from macro commands in the console. We could take that one step further and actually on the Magic Sheet page, which I just selected down here, this is Magic Sheet 1, I can add a button, and that button's target is going to be macro 1. And we'll add a second button. This is the worst looking Magic Sheet. Anyone who uses EOS is probably shuddering right now. This is macro 2. So now if we take this back to live, I can click my macro, send 1, send 2. So this would be used in the case of you have a projector that fails or multiple projectors that fail. You'll have a button that will douse one or all projectors by overriding the shutter command to 255, which will douse everything. And that will allow you to switch to your understudy or however you want to handle it. So just a really clever, easy way of controlling D3 back and adding a little bit more directly from the lighting console, because what I've found doing theatrical shows is it's mostly lighting programmers who are running the shows, and they don't particularly want to spend any time in disguise if possible. And my goal has been to move all of this in. The one last piece that we'll look at that we can't actually do is if I just bring in a rectangle and set its target to be a command, I can set that command text to be /d3/show control /section hint. And one day, my goal is to make this show the section hint. Unfortunately, it can't do that currently. It's on the to-do list. Basically, we're almost there. EOS is just waiting for a different format of OSCQ that D3 doesn't send out. So either getting EOS to accept the D3 format or getting D3 to have a toggle to send out the EOS format will get us that last little hump. So that's really what I wanted to go over today. I'm going to dump out of this because my computer is screaming at me running everything at once. So, I hope that made sense to everyone. Are there any questions about what we've gone over today? I'm keeping an eye on the chat. Got that pulled up. Oh, it looks like my channel may have actually frozen because it's not changing when I switched it back. That's unfortunate. Let's take a look in here. Oh no, it did change over. Great. So, for anyone still with us, are there any other questions? Anything you want more clarification on? So Sam in the chat is asking about thoughts on using TCP versus UDP. D3 doesn't support TCP out. It needs to be UDP. So by default, my suggestion is use UDP because of that. I would like to switch over to TCP at some point because you can see a supersaturated network that can become problematic. But that's also why D3 was nice enough in 17.1 to add in the ability to change how often you're sending messages. So in an actual show environment, I would choose to send messages every second for the transport out. And actually, this is something that I just emailed D3 about this morning that I found in searching for this. One thing I've realized is when your transport is disengaged in D3, you're still sending the information for heartbeats, for section hints, and all of that. And I feel like that's not actually what I would want, because I want, if my transport's disengaged, I'm no longer listening to inputting messages. I feel like I shouldn't be sending them out either. Um, I may be in the minority on that, so if you disagree, feel free to, but just kind of food for thought. I have had the only time I've had an issue with that is if the network is not well calibrated. He was asking if there's an issue not having the TCP handshake. And I saw it specifically on a show that was a Broadway show I was doing recently, where lighting was also controlling all of the architectural fixtures in the building. And we realized that the architectural fixtures were all on 10100 switches, and that was causing occasional packet loss where we missed a total of like 5 queues over the course of 10 days because of that packet loss. It may have actually been better being able to roll back the amount of information D3 is sending to the lighting console. And to be perfectly honest, I wish EOS had a way of tuning down what they're sending, because there are a ton of messages being sent by EOS every time you take a queue. Their OSC implementation is almost too robust. So as long as your network environment is well calibrated and you're working on gigabit switches, it should be fine. But then you enter worlds where, oh look, all the lighting architectural is 10100, and that created a very big problem for us. Any other questions from the audience? You're quite welcome. All right, I'm going to go ahead and call it for today then. Next week is a little bit busier for me, so I'm going to knock my streaming schedule down a little bit. I think Wednesday is going to be my next stream, and we're going to do a very like rudimentary introduction to networking, just for people who don't have that background, and also practice for me giving that class. You're quite welcome, Thomas. Thank you guys for watching. And it's been great chatting with all of you. I hope you have a wonderful day, and I will see you all next time.